So let's do a couple more problems. And it's just a good idea to solve a bunch of problems just to see how to think about this. So let's read this problem here. So we want to find the area of the shaded region, and it's telling us that this line here is tangent to the circles, which just means it touches the bottom of the circles. It's like this is the ground and the circles are laying on it. We know the circles have a radius of 5 centimeters, and it gives us a hint. It reminds us that the area of a circle is pi r squared. So, what do we need to find? Well, we need to find this area here, and let's insert the other information into this diagram. So they're telling us that the radius of each circle is 5 centimeters. So I'll put that in. There's roughly the center, and the distance from the center to any point on the circle is 5 centimeters. So this is a good problem. So I think this is a good idea for you guys to pause the video and think if you could come up with some way of solving this problem, or things that might be a good idea to solve this. So pause the video now and have a think about it. I'll come back just in a few seconds and I will give you some hints of the way I'm thinking about it. There might be other ways as well. Okay, so the first hint I want to give you is, well, each circle you could think of as maybe existing in a square. And how big is this square? Well, the diameter of the circle is going to be the length of the sides of the square. So each side is going to have a length of 10 centimeters. You can see here the radius is 5, so the diameter is 10, and that has to match up with the length of each side. So that is my first hint for this. Again, if you haven't come up with a good way, pause the video now and see if you can decide what a good plan would be. Okay, now that we're back, what I notice is that, well, outside of this circle, there's kind of 4 equal areas left in the square. So if I subtract the area of the square from the area of the circle from the area of the square, I'll just be left with these 4 bits. And I only want, for each circle, I want one of these bits. So we'll take that subtraction, this leftover area, whatever that is, I'm going to divide it by 4 just to get the area of one of these bits. And that'll be for each circle, and there's 2 circles here, so we'll just multiply this area by 2 to get both of these areas. So that's going to be my plan. So plan is going to be determine, and I'll just use some notation like this: the area of the square minus the area of the circle. So that's step 1. Step 2 is going to be divide by 4 to get the area of that one segment there. And the third thing I'm going to do is multiply by 2 to get, since there are 2 circles, or 2 segments, I guess. And because here's your other segment. There's my other segment. Since there are 2 circles, there's 2 segments we need to solve for in this problem. So that's my plan. Let's carry it out. So, the area of the square minus the area of the circle. Well, there's formulas for these. area of a square is, of course, just the side length squared. And the area of the circle is going to be pi times r in this case is 5, squared. And pi, for our purposes, just to make the calculation a little bit easier, let's approximate that to be 3.14. If you remember, pi is some irrational number. It goes on forever, 3.14159265335, whatever. But just to make our calculation easy enough, let's approximate pi to be 3.14. Okay. So the length of the side here of the square is 10 centimeters. So it's going to be 10 squared minus 3.14 times 5 squared. And just remember, with the order of operations, we're just squaring the r here, not the pi times r. So it's pi times r squared, not pi times r squared. Remember, you have to do the exponent before you do the multiplication by 5. So this is going to be 3.4 times 5 squared. 5 times 5 is 25. And you can quickly work this out on the side of your page if you like. And you should get that this is 21.5. So that's part 1. Part 2 is we're going to take 21.5. We're going to divide it by 4. So you could do a little long division here if you like. We're going to do as much as we can on especially midterms and exams, doing calculations by hand, so it's good to get practice with that. So 4 divided by 4 into 21 goes 5 times. Subtract 20, you're left over with 1. Bring down the 5. 4 into 15 goes 3 times. And 7. And 5. And that gives me, let me just scroll up just a second here. And that gives me 0. So we have this is 5.375. So I know the area of this area here is 5.375. The area of what's left over when you subtracted the area of the circle from the area of the square is 21.5 centimeters squared. So the area of one of those bits is what is that area divided by 4, is what we just did. And now let's multiply it by 2. So 5.375 times 2, and you can check, you're going to get 10.75 centimeters squared. Since it's an area problem, remember area is centimeters, or the whatever unit it is, squared, and our units were centimeters. So the area of the green section is 10.75 centimeters squared. Roughly, again, remember, we approximated pi to be 3.14, so it's not going to be exact, but that's pretty good. And you can see here, this is an example of using a diagram. So this is a nice diagram strategy. So the diagram in this case was already given to us, but we did fill in the information we knew, and we updated the diagram to kind of reflect how we were going to solve the problem. You can see we drew that square around our circle to indicate what we were going to do there. We're going to subtract the area of the circle from the area of the square. So if you have a problem and you can draw it as a diagram, that might help you out. I suggest that as a viable strategy for sure. Let's try this one. what is the ones digit of 7 to the 665? So 7 multiplied by itself 655 times. So obviously you don't want to calculate this by hand. It would take forever. Or even using a calculator, you'll find that if you did this, probably what would happen is the number of digits your calculator can display wouldn't be enough. So we're going to have to come up with some ideas for doing this. And maybe a good way of doing this is to just do some easy examples. So this is another technique here. So solve a similar but easier problem. All right, so let's do a few of these. We'll start with 7 to the 1. Well, the ones digit of that is, of course, 7. Let's do 7 squared. So 7 squared is 7 times 7, which is 49. Okay. 7 cubed, well, that's going to be 49 times 7, or 7 times 7 times 7. Let's work that out. And I'll highlight the ones digit in each of these first. I'll do this over to the side. 49 times 7. And when you're doing this calculation, think about what we're solving for. We're just solving for the ones digit, and that's going to be very helpful to us. So let's do this multiplication. 7 times 9 is 63. Carry the 6. 7 times 4 is 28, plus 6 is 34. So this is 343. And here's our ones digit here. And what I want to notice, or what I want you guys to notice, think about what we did when we did this calculation. This is the only digit we were interested in, was this ones digit, which was the 3. So if you think about it, what's over here, we're not really concerned about. And if you think about it, let's do the next one, 7 to the 4. So that's going to be 343, or 7 times 7 times 7, that's 7 cubed times 7. Now, what's the ones digit going to be? 3 times 7 is 21. Carrier 2. And we could keep going. We know how to multiply, no problem. But if you think about it, if we continue on with this multiplication, it's not going to affect what this ones digit is. The ones digit is only affected by the ones digit of the previous number times 7. So if we just want to figure out what the ones digit is, we know that's going to be a 1. So it's going to be something with a ones digit times 1. A ones digit that is 1. And we can just, let me just do this. This is going to be 4 times 7 is 28, plus 2 is 30. So this is going to be 3 times 7 is 21, plus 3 is 24. So 2401. But again, the 2,400, that bit doesn't matter. It's just the 1 that we care about. So if we wanted to find 7 to the 5, well, again, we're going to do, we can think of it as 2401, but really all we care about is that ones digit times 7. 1 times 7 is 7. And if we do 7 times a tens digit, it's not going to affect what the ones digit is. So we don't care about anything else. So we get that this is a 7. And if we think about it, we've already done this problem here, above here. So 7 times 7 had a ones digit of a 9. So I know that the next one, 7 to the power of 6, well, it's going to be 7. Oh, I have that. Let's do it with a line. So whatever that number is, it has a ones digit of a 7 times 7. We're going to get a 9 here. So the ones digit of 7 to the 6 is going to have a 9. And if you see a repeat calculation like that, that's great, because it means that there's very likely a pattern going on. So if you look here, it looks like it goes 7, 9, 3, 1, 7, 9, and it will repeat 7 to the 7. We'll have a 1's digit of 3, 7 to the 8, we'll have a 1's digit of 1. So it repeats in groups of 4. So that's great. What does that mean? Well, if we think about it, if we look at these numbers, we have 1, 2, 3, 4, 5, 6, 7, 8. Again, these are in groups of 4. And if you think about it, whatever the remainder when you divide a number by 4, that gives you what the 1's digit is going to be. So 7 to the 9, well, if I do 9 divided by 4, you can check that it's 2 with a remainder of 1. So that's going to have the same 1's digit as 7 to the 1. So the 1's digit of this is going to be 7. And we can do this for any number we like, since it's in groups of 4 like this. Since it repeats every 4, the remainder kind of tells us what the 1's digit is going to be. So we are interested in 655. And you can check that 655, maybe we'll just do that calculation to the side here. 4 into 655. I'm going to do something called short division here, which is basically the same, except I'm going to do the subtraction in my head and put the remainders as kind of carries. So 6 goes into 4 once with 2 left over. So I'm looking at this as 25 now. 4 goes into 25 6 times with 1 left over. 4 goes into 15 3 times with 3 left over. So I know that this is going to be 163 with a remainder of 3. And if we look here, we have a remainder of 3. So that's going to have the 1's digit of 7 to the 3. So I know 7 to the 655 has a 1's digit of 3. And again, solving these similar but easier problems allows us to notice the pattern, allows us to know what's going on. Sometimes having these huge numbers, like 655, kind of hides what's happening in the problem. So if you do some easier examples with numbers that you can deal with or numbers that you can intuitively understand, then your life might get easier when you solve a problem. So let's look at this problem here. So here we have 2 apples and 3 bananas together cost $3.10. 3 apples and 1 banana costs $2.90. So we want to know, how much does each cost? So again, we want to solve for how much a banana costs and how much an apple costs. And they're unknowns, so it's a good idea to label these. Let's use the letter A to mean apples. And so I'm going to put an equals here. I'm going to put a colon equals here. And this means I'm naming. So if you see that colon equals, it comes from computer science, but it's starting to appear everywhere. But this means you're putting a name to a variable. And the variable A, so that's our unknown, that is going to be not just apples. We have to say what about the apples we care about. We have to be precise. So we want to say the price of an apple. And B is going to be the price of a banana. And it's very important when you're defining variables, make sure you tell people exactly what these variables stand for. So this is good because we said exactly what these stand for. This would be bad if you just said A means apple and B means banana. That's not a good definition for your variables because we don't know what about the apples and bananas we care about. So this is bad because we're not being specific enough. If somebody's reading our work, maybe they'll think we're talking about the number that we're buying or the weight of it or something. But we care about the price, so we're telling people that are unknowns, the things that we don't know but we care about. They're the price of the apple and the price of the banana. So the technique we're going to do here to solve this problem is going to be, we're going to write using algebra. Sometimes it's really good. If you know some information, it's not a bad idea to write it down in the language of algebra. And we kind of started with this. We defined our unknowns, we defined our variables. So now we just have to write each equation. So we have 2 apples and 3 bananas cost $3.10. So that means I have 2 apples and each apple costs some amount. Remember that price is A, and I add that to 3 times the amount a banana costs. Well, we know that's going to be $3.10. And we know, let's do this one in yellow, 3 apples and 1 banana costs $2.90, so 3A plus 1B, but instead of writing 1B, we usually just write B. So if you just see a variable by itself with no coefficient, these are the coefficients, kind of the numbers multiplying a variable. So if we see no coefficient, it means a 1, and this is $2.90. So this is great. If you think about it, algebra is a language. And what we did is we translated our English here into the language of algebra. So once we defined our variables, we said 2 times the price of an apple plus 3 times the price of a banana equals $3.10. And that's what this says up here. 2 apples and 3 bananas cost $3.10. And similar here, 3 apples and 1 banana costs $2.90. All right. And once we have our problem translated into algebra, well, our plan, well, we can use substitution to solve these systems of 2 equations. If we solve, say, the second equation for B, then we can substitute that into the first equation, and then we'll just be left with an A there. So let's use substitution to solve for A and B. So let's go ahead. So looking at this, I noticed that there's no coefficient in front of the B, so I'm not going to have to worry about dividing both sides of the equation by something to solve for B by itself. So it's probably easiest to solve the second equation for B. So I'm going to call this equation 1 and equation 2. So let's solve equation 2 for b. So what I'm going to do, it's 3a plus b equals 290. I'm going to subtract 3a from both sides. Remember, with an equation, you can do whatever you like, in some sense, to both sides of the equation, as long as you do it to the entirety of both sides and equality will still hold. So if I want to subtract 3a from both sides, that's great. I can do that. So I'm left with b on the left-hand side, and on the right-hand side, I'm left with 290 minus 3a. So I solved equation 2 for b. There it is there. Now, I'm going to sub this in. This is equation 2. I'm going to sub this into the other equation, into equation 1. So, remember, this says they equal. So wherever I see a b, that equals 290 minus 3a. So I can replace this b with 290 minus 3a. So let's go ahead and do that. So I get 2a. Oh, maybe I won't put that dot there, actually. I'll just write it as 2a. 2a, which is the same as 2 times a, plus 3 times b. But remember, b is the same as 290 minus 3a, and that equals 310. And now if we look at this, well, we just have one equation with one variable, a, and we can solve for that. So let's use our equation solving skills. I'm going to expand this 3 across both brackets. Then we'll get all of the a's on one side, all of the constants on the other side, and solve for a. Okay, so let's go ahead. 2a plus, well, 3 times 290, you can check. This is going to be 870 minus, well, 3 times minus 3a is minus 9a, and that equals 310. Let's combine our like terms on the left-hand side. So we have 2a minus 9a is minus 7a plus 870 equals 310. Let's scroll down. So we already have the a's on the left-hand side, so let's just subtract 870 from both sides. So we get minus 7a equals, well, 310 minus 870. You can just do a little calculation. Remind yourself of how to subtract negative numbers when the negative number is larger. Well, you just keep the sign of negative and you subtract. So this is going to be negative 560. So there we go. And we want to solve for a, so I'm going to divide both sides by negative 7. Negative 7 divided by negative 7 is 1, so we just have 1a. And negative 560 divided by negative 7, well, I know the negatives are going to cancel, and you get a positive. A negative divided by a negative is a positive. So let's just do a little calculation to the side to make sure we know how to do this. So we have 7 into 560. Again, the two negatives are going to cancel, so I'm not even going to write them down. So 7 goes into 5 0 times with a remainder of 5. So I'll put the 5 over here. 7 goes into 56 8 times with a remainder of 0. So our answer is just 0.8 or 80 cents. So A is going to be, and since we're usually I would write 0.8, but since we're dealing with money and money goes to cents, I'm going to include the 0 there in the hundredths place. So we know A is 80 cents. So an apple costs 80 cents. And now let's sub this in either equation to solve for the other unknown, B. Let's go ahead and do this. So let's do this equation. 3A plus B equals 290. And we know A is 80 cents. Remember, A is the price of the apple. Plus B is 290. 3 times 80 cents is $2.40. Plus B is 290. Let's subtract that 240 from both sides to solve for B. And we get that B is 0.5. So we have that the price of an apple is 80 cents. The price of a banana, and I should maybe I'll put the 0 in since we are dealing with numbers, or sorry, with money, is 50 cents. So we have our answer, but a good idea is to check this with the other equation to make sure we didn't make a mistake. We used equation 2 here to solve for B. Let's use equation 1 to check that our work makes sense. So that was 2A plus 3B equals 310. So we get 2 times 80 plus 3 times 50. Does that equal? And whenever I'm checking things, I like to put a question mark over my equal sign to say, this is what I'm checking. I don't know if this equals holds. That's what I'm trying to find. So let's check. 2 times 80 cents is $1.60. 3 times 50 cents is $1.50. Does that equal 310? Well, of course it does. $1.60 plus $1.50 is $3.10. Does indeed equal. So that is correct. So we did this kind of a long way. I didn't go particularly quickly through here, but I do want to talk about this again just so we know kind of a good procedure when we're using substitution. So whenever you have, and we're going to talk about situations that are a little bit bigger, but I want to point out to you guys that here we have 2 equations. I'll do this in, haven't used green here yet too much. So here we have 2 equations, and they're linear equations, so there's no kind of exponents here. Each term has just one variable in it. It's not like 2 times A times B or anything like that. Each term just has either an A or a B, and there's no powers involved. So we have 2 equations, and we have 2 variables. So whenever we're in this situation, we can use substitution to help us solve. And for substitution, there's basically a few steps. So our first step here is solve either equation for one of the variables. So maybe we'll mark that as 1. So it doesn't really matter which equation or which variable you solve for, you'll get the right answer either way. So make it the easiest one that you can. Usually, if there's no coefficient in front of a variable, that's a good one to solve for. Or if there is, maybe if it's small, or if it divides all the other coefficients or all the other numbers around, that'll be helpful as well. Sometimes you can't help it and you just have to pick one and deal with a little bit of mess with the fractions, but you can still get the right answer. So once you do that, the second thing is you sub into other equation. So that is 2, that's what we did there. And we solved for other variable. So that's what we did here. We solved for A. And the third thing we did, well, we plug this in, plug in solution to either equation and solve for original variable. So that's what we did here. We solved for A, we plugged that into either equation, we picked equation 2, and we solved for B. And once we do that, in some sense, that gives you your answer. But I like to do this, especially on a test or exam or when it's important. I like to check by plugging both into the other equation. So whatever equation I picked in step 3, I'm going to pick the other one in step 4 and just check that I do get equality. Now I just want to talk about a few notes here. So the first is that chapter 1.2 has a lot of good ideas when it comes to problem solving. So my suggestion is to read section 1.2 in your book. It's not too long, it's a fairly easy read, and talks about a few more problem solving techniques as well that we'll get to in the future, but it's good to have these around. And the reason I want you to read that section is because if you're ever stuck with a problem, refer to that section. For ideas. So, a lot of students come to me and they don't know how to start a problem. The first thing that I always do is I get them to go to that section and look at the different problem-solving techniques. And we talked about some good ones in these videos, and there's a few other ones that are in that chapter, and like which ones could you apply to the problem that you want to solve. And then from there, they usually are able to come up with a good way of starting the problem. So this is an excellent and very important section for the entire course, since it gives you a bunch of techniques and tools to be able to solve some problems. The second note I want to make is to practice problems in that section. And some answers are in the back of the book. And problem solving is one of these things that becomes a lot easier the more that you do it. So we did 3 or 4 in this section on video, but I think it's a good idea for you guys just to do a bunch yourself. Some will be easy, some will be more difficult. And more difficult ones are good because they really get you to think deeply about how to solve a problem. And the more that you struggle, the more that you will find problems later on, and harder problems later on, a little bit easier. So practicing some problems, I think, is very, very important. The assignments in this course will allow you even more practice, and some of those problems are going to be quite difficult, and you'll have to struggle and think about what's happening there. It's not going to be straightforward. You are going to have to be a little creative. So I strongly, strongly suggest you do a bunch of practice problems in the material in section 1.2 for the reason that it is kind of just raw problem solving at that point, as long as you're fine dealing with the algebra that comes up and the arithmetic. There's no new ideas. Later on in the course, we'll deal with some ideas, and that'll be on top of the problem solving. So this is an excellent opportunity just to practice raw problem solving activities. Alright, so that's it for section 1.2. We'll move on in the next video.